All right, next I want to talk about precipitation and the hydrologic cycle. And the hydrologic cycle, let me advance this a bit, is the system that circulates water from one part of the Earth's system to the other, like from ocean to land or vice versa. And we're going to be talking a little bit more in depth. The hydrologic cycle is a big, complicated thing, but the two probably first key elements are evaporation and also precipitation. So let's start with precipitation. This is how water gets from the atmosphere to the land or from the atmosphere to the ocean. And you can think of it as rainfall, and it mostly is, but precipitation is a broader term that includes rain, snow, hail, different types of moisture going from the atmosphere to the surface. So this is kind of a schematic of the hydrologic cycle. The ocean loses 86 units of evaporation, gets back 78. So you can see there's a deficit there. Some of that extra moisture goes over land. Land gets 22 units and loses 14. So an additional amount, the water kind of gets some of the extra moisture from the ocean. And then that kind of makes its way back to the ocean through surface runoff and also through groundwater. And we use it in the interim for drinking water, growing crops, and so on. We'll talk about this component later, but right now I want to focus on two elements. One, precipitation, and the other, evaporation, and some other term called transpiration that we'll introduce as well. Because when we're talking about land, we count two parts. We count evaporation, and we also count transpiration. Here's another view of it. Then you have, a whole lot of different components of the hydrologic cycle, but let's start with precipitation. Precipitation is the moisture supplied to the Earth's surface. And it's a broader term than just think of it as rainfall, that's fine, but understand that it also includes things like snow as well. Snow is also an example of precipitation. So that is the moisture supply to the Earth. Now, when it comes to the other end of the equation, the total amount of moisture leaving the terrestrial, the land part of the Earth, there's two components to it. One is simple evaporation. This is how water ocean to the atmosphere, and it depends on temperature. If it's hotter, you get more evaporation. Humidity, how much moisture is in the air. When the air is dry, you get more evaporation. And also wind speed. Wind helps to move water molecules to allow for greater amount of evaporation. If you think about a clothes dryer does two things, or three actually. One, it raises the temperature, it makes it warmer. It also has dry air, so it lowers the humidity. And three, it moves the clothing around. That's wind speed. So those three things allow the water from the clothing to evaporate in a clothes dryer. Now, there's probably a less intuitive term that we include called transpiration. So transpiration is water that's lost from plants, from their leaf pores to the atmosphere. And this is a cooling mechanism that helps to regulate the plant's temperature. So when it comes to the total amount of water leaving land to the atmosphere, we include them both. We include both evaporation and transpiration. And in fact, there is a third term, which is a combination of these two terms, evapotranspiration, which is a combination of evaporation and transpiration compressed into one word. Sometimes it's abbreviated as ET for short. So this is a combination of evaporation and transpiration. And so the total amount of moisture leaving the Earth's surface is both. It is the evapotranspiration that's happening. Now, of course, with transpiration, that is evaporating, but one way to think about this is if you're a farmer and you are growing a crop, of tomatoes, let's say, and you want to know how much water that you're going to need for irrigation. These are two things you'll need to account for. One, you'll need to know how much water is evaporating from your field simply from the water itself into the air. And secondly, you'll need to know how much your leaves of your plants are transpiring through the air. And so that combination, so for example, in California, there's a weather network that helps farmers calculate their evapotranspiration so they can better calculate how much irrigation water they would need. So when it comes from the land, the total amount leaving is both evaporation and transpiration, or evapotranspiration. So instead of just saying evaporation for the total amount leaving, we use the bigger word, evapotranspiration. You get less of that when conditions are wet and cold, and more when it's warm and when you have warm conditions. Kind of intuitive. And then one other term I want to introduce too when it comes to evaporation is the term potential evaporation. This is how much evaporation would occur if you had water available. And so let's think about Death Valley, California. Dry desert, no surface water to speak of. Now, Death Valley would have very low amount of evaporation because there's no water there. However, it would have a high amount of potential evaporation because if you were to fill it with water, then a lot of that water would evaporate had it been present. So the way they measure that, this is a tank of water. They look at how much evaporation happens in a tank like this, and that's a way to measure the potential evaporation.